Welcome to this seminar in our international series of TAPAS. As all of you, I think, know, TAPAS is a network which is looking at air pollution in schools. And we've, over this last term, have been focusing on developing international connections with TAPAS, as we're in the final stages of the project here. Before I introduce the speaker, let me just make the usual housekeeping remarks that please put your questions in the chat as you go on, and we'll handle them at the end of the presentation. And I should just tell you that this will be recorded, and will be placed on our website at the end. So it's a great pleasure for me to introduce Olivia Ryder. She is the Program Manager of Kids Making Sense, an air quality educational program. Her current data analysis projects focus on community monitoring and helping underserved communities, analyzing ambient data for toxic metals as part of community air monitoring efforts, conducting source apportionment assessments, and working with the US EPA to develop best practice guides for mitigating air pollution in various environments. I've discovered in talking to Olivia that she worked with someone I knew well when I was at UCSD, when she did her PhD and postdoc there, a person called Kim Prather. So I know we're in good hands this afternoon. And in particular, in her role as program manager for Kids Making Sense, she coordinates closely with teachers in schools and community groups. And I think that's very important for us. We like to do that. And so we hope we'll get some pearls of wisdom from you, Olivia, about that. So without further ado, I will hand over to her and let her talk about Kids Making Sense. Thank you very much, Olivia. So if you'd like to share your screen,
Yes.
You can go from there.
I think you should be able to see it now. Perfect.
Yeah, that's all good. That's all good. Yes.
Okay, perfect. Thank you so much, Paul. Thanks so much for having me here today, and I appreciate you all coming at a time that's not your usual meeting time to accommodate the time zone that I'm in. So as Paul mentioned, I'm Olivia. I work for a company that's called Sonoma Technology. And I have a sort of split role there. I'm both an atmospheric scientist in a data sciences department, and I also manage the Kids Making Sense program. But in this talk, I'm going to be sort of describing how we use the Kids Making Sense program and the power of collaboration to empower students to create change, to expand their understanding of the air that they breathe, and to acquire skills to become advocates for air quality in their own communities. And though you probably can't tell by my very odd accent, I was actually born in England. I grew up there until I was about 14, and then I moved over to the US. So if you're wondering where I'm from, based on my confusing accent, that's where I'm from. And this is what happens when you live in the States for 23 years. Your accent sounds somewhat Australian. So this is just a brief outline. I'm going to go through sort of what Sonoma Technology does, then what is Kids Making Sense, give a very brief history and sort of talk about the mission of the program. I'm going to talk about how it works, some program details, and then example case studies of implementations and significant outcomes that we've had from the program. I have about 30 slides. Not all of them are real slides. Some of them are just sort of, in between slides. So I'm aiming for about 30 minutes of this talk. And then I'm more than welcome questions as well. So a few brief slides on Sonoma Technology. We're an air quality consulting small business. We're located up in Northern California, in a small town called Petaluma. It's in Sonoma County, hence the name of the company. We've been providing innovative science and technology solutions for the past 40 years. And we work with groups from all over the world. Despite the fact that we're located in California, we've got offices all over the country. And we work with groups from, as I said, all over the world. And what we do is we provide these comprehensive end-to-end solutions. So we work in all sorts of projects, areas related to air quality. So that could be planning data collection to setting up measurements, to data analysis, all the way through to training and education of different groups. And then one last slide about Sonoma Tech before I switch gears here. We have an expansive landscape of expertise on our team. So we're all related to air quality in some form. So that's from climate to community air monitoring, which is what I focus on in my data analysis side of things, through to wildfire modeling and transportation. Wildfires obviously being a pretty hot topic here in the US, especially out in the West. And we work with a variety of different groups on these projects. So from community groups to the US EPA, as Paul mentioned earlier, to international groups like the World Bank and C40. And so one of the areas that we work in is education and outreach, and that's where Kids Making Sense fits into sort of the whole scope of Sonoma technology. So let's now switch gears to talk about Kids Making Sense. So this is an educational program, teaches youth how to measure air pollution using low-cost air quality sensors, how to interpret the data that they collect, and then how to take action to reduce emissions, or more importantly, especially for young people who can't, who don't always have power over where they live, or, certain other things, how they can protect themselves from air pollution, so how they can mitigate their own exposure. So the program history, the program and its tools were developed before I joined the company, so over the course of the past 10 years, and it's really evolved to the point where it's at today. It was developed originally with support and collaboration from the US EPA's Office of Environmental Education, but we've had since input from air districts, from teachers, and from community groups. And again, it's really evolved to the point where it's at now. And to date, the program's been used in over 400 classrooms, both here in the US and also abroad. And you can see some of the locations in the photos that are noted there. And I know I'm doing a lot of background and I haven't actually explained exactly what we're doing, but just bear with me for a few more slides and we'll get there, I promise. So the mission of Kids Making Sense is sort of threefold. So first, it's to provide high quality, innovative, science-based kits for air quality education worldwide. It's also to provide unique and comprehensive curriculum for students to use. And then our goal is really to empower youth with the technology tools and the background information to measure the air and understand how best to protect themselves. So sort of this trifold mission statement here. What we found from running this program over the past 10 years is the benefits are, the program itself allows for, hands-on student-initiated inquiry and inquiry-based learning, really allows students to have this increased awareness of their own pollution exposure within their communities, often that they haven't actually recognized in the past. It empowers students to drive for positive change during a time when they're forming their own transportation and consumption habits. So during that sort of late primary school into secondary school timeframe. And then it provides students and community groups opportunities to interact directly with air quality scientists, which I'll talk more about in a few slides here. And then lastly, the material includes information on recommended actions that students could take to lessen their exposure, and also to interact with policymakers. If that's something they want to do, nobody's forcing anyone to talk to politicians if they don't want to. It's just a next step that can be taken if they choose to go that direction. And again, I know that I haven't talked about the program itself, but before I do that, I do want to talk about how this is typically implemented, because you're probably thinking, well, you're a consulting company, how does this work with all these groups? So I just wanted to describe some of the ways that this program is typically implemented, and then I'll go through the whole program itself. So the first way is through local organizations. So the way that this works is local organizations will reach out to us, they're interested in the program. We can then sort of identify some grants that they might qualify for that we can jointly apply for. We put in those applications, hopefully are funded. We then allow them to identify the schools, or we work together to identify the schools. and then we provide training directly to the teachers, and then we sort of, work together to run the program. Another way is through government agencies. So it's very similar, but we work with government agencies. Sometimes they have already sort of scoped what it is that they would like to do, or the schools that they'd like to work with. We either jointly apply for grants again, or we use existing funding that they might have to implement the program. Sometimes what they do is integrate it into their own program, which we've seen with South Coast Air Quality Management District, if you're familiar with them. It's a large prominent air district here in Southern California. So they've integrated this program into their own program, which is totally fine. We trained district staff so that they then could go on and train or bring the material to the classrooms within their district. It's a very flexible program, and I'll probably say that about 8 more times before we're done here. And then direct to teachers. So sometimes a teacher or a professor from a university will express interest in a kit. They might purchase a kit directly. And then we can train the teachers, the professors, or grad students, whoever it happens to be, very flexible in who exactly it is that we train there. So this is just sort of 3 different flavors of how this program runs. But again, it's very flexible and can be done in a multitude of different ways. So some of the groups that we've worked with are noted on this slide, and I've also noted the locations where we've worked with them. One that I did want to bring up is let me see if this works, the CATS team here, which is at Newcastle University. So they're based obviously in the UK, and they brought the program across the UK, also to India and to Barbados as well. Their primary focus is on helping students learn about the Sustainable Development Goals. And so they've incorporated aspects of Kids Making Sense into that program. So again, very flexible. You don't have to do the whole program. You can pick and choose what makes the most sense for the students you're working with, and you can implement it that way. Okay, so now we'll finally get to what Kids Making Sense looks like and what it is. So Kids Making Sense. So we have a variety of kit types that groups might reach out to us with interest in. And so these are sort of the current offerings that we have. And these are the ones that people could reach out to because they've seen them on our website. We also develop programs for people as well. We develop curriculum modules depending on if they have, particular interest in a certain topic. Maybe it's wildfires, maybe it's asthma, things like that. So we can work with people to develop additional modules to supplement what we have on offer here. But air quality kits, that's what I'm going to focus on today. We also have a Sense Alone program. So this has been really popular with community groups who want to engage community members with this type of material. And those community members aren't always, young students. So we have a version that sort of works well with people loaning these out at libraries. And so that's what the Sense Alone program is about. We also have a weather school kit, which includes weather sensors. We have a builder sensor kit, so students can actually build their own indoor air quality sensor, which is hooked up to a computer, and they can learn about the components of these sensors as they're building them. We have an advanced curriculum which goes into topics like environmental justice, data analysis, or more in-depth data analysis, and science communication as well. But today, as I said, I'm just going to focus on the air quality kits. So let's talk about sort of the program components here. And I apologize that these have turned out as gray blocks here, but just bear with me. So the classroom kit itself, so that's sort of this one that I'm showing here in this small picture, is completely turnkey. Or that includes the reusable items and the consumable items that a teacher would need to implement this program in their classroom. As I mentioned, these kits, well, I may not have mentioned, but these kits are reusable year after year. The consumable items after a period of time would need replenishing, but they're things like index cards and rubber bands. So they're not things that are super taxing to teachers. The reusable items in there are obviously the sensors, there's mobile phones in there, there's a vacuum, there's all sorts of things that are needed to do each of the modules that are in the curriculum itself. So speaking of the curriculum, It's a very flexible curriculum, and there's about 8 modules in it, which we'll talk about in a couple of slides here. But it includes a student workbook, and that's geared towards grade ages 12 through 18. It also includes a teacher's guide, because we want to make sure that teachers are as prepared as possible to deliver this material to their students. And so we've included a full teacher's guide with all of the information that they might need, including sort of cautions and adjustments, all sorts of things. It's very adaptable. So as I said, you can pick and choose modules that might work best with a class, or with topics that you're already teaching, and those modules can completely stand alone. The next main component that I want to sort of focus on is the actual sensors themselves. So these sensors, I usually have one in front of me, but I'm traveling right now, so I don't have one to hold up, but they look like that little picture in here. They measure particulate matter, and they allow for sort of an interactive data collection experience. As students walk around, they'll see the data that they're collecting as they're collecting it. It shows up on a map or on a graph, and I'll show you examples of what that graph looks like as well. You'll also notice that this sensor is see-through, and we did that purposely. So the sensor itself was based on a design of another sensor that exists on the market, but we wanted to add the additional sort of enhancement of making this clear. Each of the parts on the PCB board in that sensor are labeled, so students can see exactly what each of the components is. And we believe that this allows sort of quite literally to take out the black box component from the measurements, but it also engages students on a different level. It allows them to sort of think about the components that are going into some of these electronics that they're using. All of the data that's collected on the cell phone and the sensor is automatically uploaded to a crowdsourced website. So students can then go on and visualize the data that they took after they took it. They can go in and investigate exactly what it was, where they were. It's on a GPS map, and I'll show you an example of this as well. And this is a crowdsourced map, so anyone can go on. You could go on right now if you wanted to check out the map. You can look at all the different sessions that have been taken, and students can use this to then compare their session and the data that they collected to maybe a classmate or to a different school or to somebody in a different country, right? So there's lots of different ways that this can be utilized as well. And then finally, we have 2 optional sort of components here that sort of pair really well with the rest of the things that I've just mentioned. That's the chat with the scientist. So this is where one of the scientists from Sonoma Technology comes in sort of a virtual classroom visit, can answer questions about projects that students might be doing with these sensors, or answer questions on, just being a scientist in general, which often is what students ask about. And then teacher training. We found that this is incredibly valuable. We work on the train the trainer model. So we teach teachers who then can go on and continue to teach students, right? Because we're not the ones qualified to teach students, but we can definitely do training. And we have different formats for that. It can be virtual, we have pre-recorded videos, and we can do in person, depending on time zones and sort of what best suits the group that we're working with. So the curriculum itself in our standard curriculum that comes with that with that classroom kit has 8 modules in it. Again, no teacher has to go through all 8 of them, completely flexible, but it starts out talking about sort of what's in our air and what is pollution, then starts to focus in on particle pollution, because that's what they're going to be measuring. Talk about particle sources, so where they're coming from, especially local sources around where students live. Then move on to health effects of particles. And I should stop and say each of these has an activity or a hands-on component associated with it. So in the health effects of particles, students get to measure their own lung capacity, which is always a fun one. They then go on to talk about how particles are measured by regulatory agencies and also in the sensors that they'll be using. And then they get to mimic how the regulatory monitors work. Module 6 is the actual air sensor experiments. They get to go out, design their own experiment, collect data themselves, come back. Data analysis and interpretation can be done individually or as a class. And then lastly, being part of the solution. So taking what they've learned and engaging others with that information. And that's where if they did want to sort of reach out to policymakers or other groups, they could definitely do that. Or they can keep it in-house and sort of just engage their peers and other folks in the community. And there's various approaches for this sort of field measurement experiment. The way that it's written is that students or teachers can create a walking path for students to investigate. Again, depends on the level of student that you're working with. But you can also devise science questions and take that approach as well. And that could be indoor or outdoor science questions as well. So these sensors can be used in either environment. But I just wanted to point that out because we do have a lot of people that go in the science direction focus, and that's what I'll talk about a little bit later as well. Sort of talked about the sensors, but just a few more details. They measure PM1, PM2.5, and PM10. They use a plan tower, which I'm sure you're all familiar with. They can be used indoor and outdoor. They're used as students move around, but they also have a stationary mode, so you can use them in that mode as well. Allows for this real-time mapping of PM concentrations. I mentioned about the clear casing. And what's happening is it's communicating via Bluetooth to the cell phone. The cell phone's what's doing all of the data logging. It's also doing a data display for you. So there's an app that goes along with this that so these two have to be next to each other as you're taking a measurement session. However, you don't have to be within Wi-Fi range. The cell phones don't have SIM cards in them. They're just being used for the Bluetooth capability. Yeah, so I just wanted to point out those few details. I'm going to skip this slide because I feel like I've covered it pretty well. So once students have gone out and they've sort of collected their measurements, they come back and they can then look at their sessions on the web interface, which I mentioned before. And so I'm just going to play this video. This is what it looks like though. So students can see the graph of the data that they've collected. And then they also have a Google map with an overlay of the session as they walked it. You can then investigate that session. And so you'll see that as you zoom in, you can sort of scroll over the walking path and you see exactly where you were on the graph itself as well. And this can help students try and identify, okay, well, why was there high measurements in this particular location versus this other location, and what could be playing a role there? Because it is a Google map, you can change, obviously, the base layer of the map itself. So you can change it to topography if topography is playing a role here. So you can see where this session was taken was in a valley, though that wasn't actually playing a role in the data that was collected at this particular time. But it also makes it sort of more interactive, and it allows students to really investigate what might be going on if they didn't take those observations as they were walking around. Also allows for students to share these sessions easily and to export the data if you would like them to work, with the data in raw format or do additional data analysis. So there's lots of ways that could be done as well. Oops. There we go. Okay. So now that I've sort of talked through what the program is and sort of how it runs, I wanted to highlight some of the ways that it's being used by community group or by groups that we've worked with, and sort of the range of outcomes as well that can come from this program that we've seen from its implementation. So there really is a range, right? And it spans all the way from engagement to really getting involved. So we've seen increased engagement in STEM. We've actually also seen from teachers increased performance on standardized testing here in California, related to air quality, obviously. There's sort of this hands-on experimental experience that they gain. They get to measure levels of exposure during their day, in some cases, if that's the way that they choose to run the sensors. They actually do start to recognize sources of pollution. I have a good anecdote for a couple of slides here where we worked with some groups in India, and the students started to actually recognize and point out like, oh, like this is a problem. So that's, another great awareness outcome. Mitigation measures, so they start to recognize ways that they can protect themselves from that pollution. We've also seen students start clubs and raise awareness at schools and in their communities as a result of this as well. So one of the, maybe the most dramatic outcome from this program is this example where we worked with a community group called Coalition for Clean Air. They're located in California. They sort of do work throughout California. And they identified classrooms for this program, and one of them was in Rosemead, California. It's in Los Angeles County. So what happened in this case was a teacher led the students. They decided to go out and measure local pollution sources. One of them is a freeway. And so they decided, okay, we're going to go measure over this overpass. It's probably going to be quite high levels. Afterwards, on the way back, they stopped at a fast food restaurant to get a drink, but they didn't turn off the sensors. And what they actually found, as most science goes, is not what you expect, right? But they were shocked to see that they actually had higher concentrations in that fast food restaurant than they did on the freeway overpass, which was what they were originally going out there to actually measure. At the end of their sort of program, and this is a great way to do it, the community group had staged sort of a poster session, a showcase. There we go, a showcase for the students to talk about what it is that they found. So each of the groups talked through them. This group talked through what they had found. And in the audience was actually one of the members of the local Air District Board, as well as a school superintendent and a school board member. But what happened is they presented this, and what's going on, I should probably mention, is the charbroiler situation in these restaurants and the lack of decent or adequate ventilation that's causing these levels to be so much higher. And so what happened was, when they presented their findings to the board member then went back to the actual board of the air quality district and said, hey, this is a problem. Like, even students, like students have recognized this is an issue. We should really be doing something about this. And so the board agreed to prioritize reconsidering the existing charbroiler regulations in the entirety of the South Coast Air Quality Air Basin, which is a huge, huge part of Southern California. So this is really, like the gold standard of what can happen is you can change regulations and have these things reconsidered if you put the equipment in the hands of students. This is, an outcome that can happen, although we realize it's not going to happen all the time. But this is a pretty stellar example of what can happen when you have students who are interested in this type of material and you give them the tools. I mentioned the Kids Action Through Science program previously. They've taken the program to India. And so in India, obviously, very different set of problems and sources of air pollution. They worked with students in an informal settlement called Jagdamba Camp. These students had not experienced these sorts of pieces of technology before, but they were very interested. So before using the sensors and seeing the data, the students knew that sometimes their air was bad in their community, but they hadn't made the connection as to the sources or like where it was coming from or how they could protect themselves from it. And so what ended up happening is we asked them, well, where is the pollution? Where do you think pollution is coming from? They identified, maybe a welding shop. There's a road, a very busy road nearby. They're also adjacent to a crematorium with open burn. So they're really, really impacted by a lot of sources. And so you saw in the second image here, the measurement showed these sort of high peaks on top of this already high background, which just exists in the, in the Delhi area. So this was when they were walking past these pollution sources. So when they walked past the welding shop and the crematorium and the roadway. We also worked with them on some of the weather aspects as well. So we sort of tried to incorporate the air pollution and the weather. But basically, by the end of this, what we were able to do is sort of help them identify these types of sources of pollution, make the connection that this is, what's affecting their lungs, and then sort of make the connection to what they could do, right? They're really stuck. They're in this very small informal settlement. There's not a lot that they can do about the location, but there is an open space there where there's faster wind speeds, which can clear out some of that local pollution. And so that's sort of how that's the connection that we tried to help them make, spending more time in this open area where the pollution is lower might help you out, when some of this local pollution is very high. But obviously a very, very different situation. Speaking of very different situations, we also worked with a private school in India as well through the CATS program, Shiv Nadar School. They were in a part of Delhi where it's a little bit less polluted. So in this case, students sort of had a lot more of a background information about where pollution is coming from, what can be done to sort of stop it. So we equipped them with these sensors, and then they went out and measured around their school where they could, find the highest and the lowest sort of PM 2.5 levels. So some of them went out and they measured at the buses, which was obviously a very high source of pollution. But it is, how they travel to school. So it's an important way to think about, okay, well, maybe we need to protect ourselves when we're around these buses and they're idling. They also went into the classrooms and measured near the HVAC vents to see if the HVAC was actually filtering out the pollution that exists outside. So that was kind of a nice pairing of outdoor pollution and indoor as well. And yeah, their solutions of sort of ways to minimize pollution in general was carpooling, electrification of buses and vehicles, so very different thought processes than the informal settlement students had there, just because of the different environment that they live in. And they thought about ways to protect themselves from traffic pollution as well. So masking was the main way that they thought would be helpful there. And then I have one last case study here, which I'll just click through. So I mentioned buses idling. This is obviously, especially here in the US, an issue that can arise because a lot of places bus students to school. So in this case, high school students were concerned about pollution from idling vehicles at their high school. And so they set up a program. They sort of, went in, this is how we're going to measure everything. They took their measurements. They actually found out that there wasn't an idling problem at their school. But in taking their measurements, they realized that the buses at the adjacent middle school were idling. So they went and did some measurements over there. And then what they found was, yes, the middle school did have an idling problem. So they didn't, but the middle school did. So they worked with middle school students to then implement an anti-idling campaign at their school to try and improve the air quality for those middle school students. So this is, something that's, it's obviously not as crazy as, or not crazy, but it's not as widespread impactful as the first example that I gave, but this is still incredibly impactful to those middle school students. So there's really an entire range of different outcomes that can come from this, whether even just raising awareness in these students on ways to protect themselves, I feel is a huge win. So I just wanted to sort of give a whole range of different outcomes that can come from this type of program. Just keeping an eye on the time here. I have a couple more slides. Where am I at with my slides? Yeah, so I have some examples, sort of other ways that are sort of science-based that students can use and have used these sensors. So doing indoor versus outdoor comparisons, sort of we mentioned that in one of the examples in India. In this case, a student did do sort of a very simple indoor versus outdoor comparison. She put together an entire poster on it and presented it at a regional EPA sort of science fair student showcase, and actually came in third, which I think is fantastic. But it's just, it's a very simple concept, right? Inside versus outside measurements, and trying to understand, okay, well, is it cleaner inside? Is it cleaner outside? What's the reason for that? What's happening inside that could be making it worse or better? Lots of different ways to use these sensors. Another one that students like to investigate often is indoor or outdoor, I suppose, is cooking, and how you can use different mitigation methods to sort of reduce PM levels, right? So hood vents, windows, fans. How is that affecting what we're breathing in the house? Are there different parts of the house that are being affected when we're cooking? It might not necessarily just be the kitchen. And then how rapidly do these various mitigation methods actually clean the air out? And then the last example that I'll give here is personal exposure, right? So students might be interested in understanding where the highest level of pollution is that they're impacted by during parts of their day. And so just hooking one of these sensors onto, a backpack when they're commuting to school can really help them understand, okay, well, what was I doing at, 7:45 a.m. Okay, well, that was when I was like walking down this road. Okay, well, let me think about, okay, well, what was happening on that road? Was there a lot of traffic? Was there buses there? Was I walking past a construction site that was active? And then they can think about ways, okay, well, how could I lessen that exposure if it was very high, right? Maybe that's using a different route or crossing the street, wearing a mask, things like this. So always trying to take the data and then pair it to a way that they can act to help protect themselves, because we don't just want to, alert them to a problem and then leave people hanging. So obviously want to close that loop there. Okay, so in summary, I think that these small sensors are really a key interactive tool that can be worked into school science curriculums to encourage sort of this active learning and exploration of the environment. Really empowers students to investigate the air that they breathe and to take steps to then make changes or to mitigate their own exposure. And there can be meaningful outcomes that can result from this type of work, right? And those can have a direct impact on students' lives and health. What we found through running this program is that it's really important to ensure that teachers are comfortable with the technology. That's why the training is often so important. Because if they're not comfortable, they're not going to use it with students, right? And then we lose out on the whole point. And there's training, obviously. We found that aligning the curriculum or the individual lessons with national standards, especially here in the US, then makes it easier for teachers to work this into their teaching plan. And so that's what we've done. We have in the US, there's next generation science standards and Common Core standards. And so this entire curriculum is aligned to those currently. Doesn't mean that it couldn't be aligned to another set of curricula another set of standards if another group wanted to use it in a different location. We provide continued support and interaction time with scientists for students, and this helps build interest and success in the program. And then always encouraging teachers and students to present their finding at science fairs. We find that takes it to that next step, right? It allows students to get their work out into the public and enriches their experience and can build confidence in the students themselves in sciences and communication skills as well. And with that, I've posted just here our website on the left, and then we have a newsletter that goes out quarterly on the right-hand side. And if anyone has any questions after the presentation, I put my email at the bottom as well. And I would be happy to answer any questions.
Thank you very much, Olivia. That's really fascinating and a great effort, I must say, and many things I think are of interest to us. And I see there are quite a few questions in the chat. So why don't we just go through those to start with? So Peter Diamond asks whether your course covers composition such as toxic traffic emissions or infectious bioparticles like COVID.
Yeah, so that's a really great question. So in the module that talks about particles, so it starts out in our pollution and sort of what's in the air, and then it goes into particles. We do talk about chemical composition. And sort of, because that's then important for like sources as well, right? So that's the next one down. So we do talk about what these particles are made of and how that affects sort of what size they're in as well, what size regime they're in. Obviously, these sensors aren't sophisticated enough to, unfortunately, to measure those differences, but we do absolutely make the point of that these are made of different components, and those can have an impact as well. We don't go into the COVID topic. This was created before COVID. And we try to make the point to teachers, because we know that that's a hot topic in their mind, that these aren't measuring sort of COVID. You can't necessarily make that link through to, okay, well, there's a lot of particles in here, so how, is that a COVID risk or not? Is, CO2 would be a better sort of indoor ventilation metric for that. But yes.
Yeah, thank you. And a sort of related question from Leela Corsi. So she says, does the program cover indoor generated pollution? Things that only come from indoors, like, for example, CO2. And I guess you don't measure CO2, is that right?
So we don't measure CO2, but we do talk about indoor generated pollution. I'm actually working with a tribe in Northern California. They're very interested in indoor versus outdoor comparisons. And so we're writing a module that's completely focused on indoor versus outdoor, sources, and how outdoor pollution can infiltrate indoors, and sort of all the implications of that, but not CO2 or the airborne viruses. We focus purely on PM1, PM2, mostly to PM2.5 and PM10.
Yeah, I mean, in sort of in contrast to what we have a program here where we've been quite heavily looking at CO2, measure PM and CO2, and I mean, I think the kind of reasoning behind the CO2 measurements are that it gives you a measure of the effectiveness of the ventilation, obviously, and so one of the things that you can do is to see whether with adequate ventilation and small CO2 levels, PM is also low or not, and sometimes it's correlated and sometimes it's not, obviously. Depends on the circumstances. And we have quite a big program in schools. Perhaps we might talk about that at some other point, but if you're interested. And Peter also asked the question whether we can get these kits and courses in the UK. I presume we can if Newcastle University have them. Is that right?
Yeah, exactly. Yeah, if you reach out to me, we can definitely have a discussion about the best way to set it up and to get it over to you. But yeah, so we have a distributor that we work with, so we can ship anywhere in the world, and sort of the training can obviously happen as well. So yeah. Not a problem anywhere.
Right. Another question from Amber Titchener. Did you follow up after the campaigns and actions to see if there was any difference in pollution levels?
Yeah, so that's an interesting question. So most of what we focus on is, or maybe this is I'm assuming this might be in reference to the example that I gave about the fast food restaurants. So we didn't follow up on whether there was changes. As you know, sort of implementation of changes at a regulatory level can take some time to actually, come to fruition. But if that question is to do with that, then unfortunately, no, we haven't followed up. However, we assume that South Coast, the Air District, has followed up. And then if it's to do with sort of more on the students and the measurements that they've taken, we're really focused on sort of their mitigation. And when they do implement like anti-idling campaigns, that will reduce the pollution, but we don't necessarily follow up ourselves on that. But that is a really good question.
I mean, sort of related to that, and it's not in the chat, is the issue of you by giving the kids and the teachers information, for example, about pollution levels, and then you wonder how much agency they really have to do anything about it. And have you come across issues where you raise anxiety but no solutions, or is that something that
Yes.
How do you deal with that question, really?
So we have had teachers bring that up during trainings. They were very worried about sort of this, like, I think one of them referred to it as like climate anxiety, or raising anxiety levels. And which is why we really do emphasize, okay, well, now what can we do to protect ourselves, or what can we do to help the community? So we really do try to emphasize that next step, and not just leave people, like I said, leave people hanging with like, oh, there's a problem, and then no solution or no way to protect yourself. So we really do try and emphasize that last component there, because it's so important.
Yes. Yes, I agree. And Mark Winterbottom, who's part of our Faculty of Education here in Cambridge, asks how you measured, or did you measure, increased engagement in STEM?
Yeah, that's also a great question. So we have, I should have linked to this. So we've run programs where we've done evaluations of the program. Obviously, most of the feedback is anecdotal from teachers and their sort of experience, right, with the program and how they feel that it has sort of altered their class and their students. We have an entire, sorry. So I've worked with Spokane Clean Air Agency. They're located in Washington State. They implemented a program across their county this past year. It was a pilot program. So we did a full evaluation of the program. That report is available online. I can send it out if folks are interested. And so we have that sort of information from there. And then we've also written into, I think we have something like 7 proposals that are outstanding right now. We've written evaluation into those as well. So that's sort of how we do it. We do have an evaluation stage to sort of gauge, how this is affecting people, if things need to change, how students are receiving it, those sorts of things. Yeah. And I can link you to that report if you'd be interested.
Yeah, thank you. And I guess the other question I have is sort of, I mean, we found our teachers are quite busy.
Yes.
That way. And so in a sense, getting them to take on something which they often see as an extra issue is something. I mean, how have you found that?
Yeah, no, that's an incredibly good point. So we've also struggled with that. What we found is you really have to find those teachers who are super passionate about this topic in order to implement it. We've also found that by taking on grant funding, especially here in the US, and providing this to teachers free of charge can help sort of encourage them, right? They are incredibly busy. So we do, again, super flexible. So we try to emphasize the fact that they don't have to implement all of this. They could just do one. Maybe they're teaching, a biology class, and maybe they just focus on the health effects module. There are standardized tests here in the US, advanced placement exams, and I think one of them is about air pollution and climate. And so there are ways to sort of feed this in. It depends on the sort of group that the class level that you're working with. But also this can be implemented in an after-school program. So if a school has an after-school program, you could run it there as well. It doesn't have to necessarily be in the classroom in a formal setting. So again, trying to make it as flexible as possible to make it so that teachers can implement parts of it. And if they see success, maybe the next year they implement a little bit more. But yes, you're completely right. Teachers are already overtaxed, I think, in all countries. So it is a bit of a challenge sometimes.
And the final question, I think, again, from Peter Diamond, he says, indoor-outdoor ratio can tell you about air cleaning filter efficiency for existing ventilation systems. Can the sensors be used for air cleaner control?
Yeah, so I think I see what you're saying there. So because you use them to tell sort of, do that indoor-outdoor ratio, and absolutely. That's one of the things that we're writing into this curriculum, this module that we're writing right now. It's also on one of the best practices that I'm working with on the US for the US EPA. That's actually one of the strategies that we're telling people to use, especially during wildfire situations, is to use an air sensor and then to sort of measure indoor and outdoor and sort of use that, well, maybe not outdoor, wildfire is obviously terrible, but use that indoor value to tell you more about whether your filters are working effectively or not. So yes, absolutely.
Okay, well, I think we've had a very good discussion following your excellent presentation. Thank you very much. Just to say that following this talk, the presentation and slides will be on our website, and Kat has put the web address for those of you who don't have it in the chat, and also the note that we always make, which is that this is TAPAS is a network, and we're happy to have anybody join. And there's a link, and you can just contact Kat via email. Next week, we have Stephen Griffin from the Leeds Institute of Medical Research to talk about overview of COVID in children and the need for mitigation in schools. We revert to our usual time of 1 p.m. next Monday. And so I hope to see all of you join us for that. And again, just let me finish by thanking Olivia for delivering a lecture at 8 in the morning in California time, which is much appreciated. I know Americans get up early, but it's still hard to give a talk at 8 in the morning, I think. So you've done a fantastic job, and it's been very nice to meet you, and I hope you'll keep in touch with us. We have ongoing programs here in schools. I mean, just to say that we have not through TAPAS, but through a related program called SAMI. We're putting CO2 and PM monitors in 1,000 schools in the UK to try and get national statistics of ventilation and pollution levels in schools, and correlate them hopefully in the long term with medical information and so on. So stay in the loop, and I hope that we'll continue to interact in the future. So that's it from me. So thank you all for attending. And again, special thanks to Olivia, and we'll see you all next week at 1 o'clock. Okay, bye-bye.
Thanks so much.
You're welcome.